We tested to see if Prevnar's rate of appetite loss was different, not higher, not lower, just different than competing medicines. So we ran what's called a two-tailed test. Now what I want to do is, I want to go in here, and I want to run this test again on data, on stats, with that sample size of 10. With that sample size of 10, okay? And I want to draw it, and we know what the result was. We got a small, but not terribly small p-value of about 4%. And we got a -2, yeah, there it is, -2 on the test statistic. Many statisticians, and I've got a couple of homework problems attached for this for next week, will never run one-tailed tests, they'll only run two-tailed tests. And here's why. Suppose they want to run this test to see if there's any change in IQ. They don't want to pick which way it goes, left or right. So instead, they run a two-tailed test. It's the same data, which means you're going to have the exact same test statistic, but look at the shading on the graph. You now have shading on both sides. You see how your p-value is related to the old p-value? It's exactly doubled. It's exactly twice. The last one was like 3.5, 3.7 or something like that. This one is now exactly double that. The reason a lot of statisticians will run two-tailed tests exclusively, it's harder to get significance with a two-tailed test. So the only way you're going to get a small p-value is if there's truly an extreme case. You see how this wouldn't be significant at 5%? It's over 5%. It was significant with a one-tailed though, correct? So a lot of statisticians say, I only run two-tailed tests. I only run confidence intervals, so to speak, because that's got higher levels of, higher burden of proof, if that makes sense. It's a higher burden of proof for the data. The data has to really prove that it's truly different. Now, going back to our original exercise, if you take a look at the t-test on a sample of 61, would it have mattered? Would it have mattered with our sample of size 61 if we ran a one or a two-tailed test? Not when it's that extreme. Check it out. The p-value is still going to say 0. It's just 2 times whatever the other one was. The other one was what? 0.00003? This one will be 0.00006. Does that make sense? It's still doubled. And the reason a lot of statisticians like that two-tailed test is for this burden of proof idea. They like the burden of proof because they like the idea of making it as possibly as significant as possible. That didn't come out right. As significant as possible. Higher burden of proof. Fair enough? So that explains the two tails, Renee. It's when the statistician doesn't want to pick a direction. Even if they have a gut feeling that it's going to be lower, let's run a two-tailed and see if we get significance this way. You can always claim significance one-tailed once you've gotten it twice. You just can't go the other way, can you? Yeah, exactly. If you get significance with one tail, that won't necessarily correspond to 2, as we just saw. So that's more of a mathy comment. But and like I said, I have either a homework / quizzes to do for next week as well. Get into that idea more. Cool. Good question. Other questions you guys have right now? Let's do a couple more of these. I like t-tests. T-tests are good, especially because of what Michael said about the extra added benefit of looking at the outliers and seeing if they actually have an effect. That's good data analysis. Take a look at some speeding data. Oh yeah, there you go, Laura. We got 2 data sets. Speeds along a certain road. We got a neighbor worried about car speeds on that road, and we got cops checking the speeds on the same road. Say again?
So that's a busy road.
That's a bit, well, it can be. Yes, it can. Well, I mean, most roads have this kind of traffic, I would imagine. It depends on how much time it took to collect this data. So the question now is, which, if either of these data sets, give good statistical evidence that cars on average are speeding? Which, if either? So take a look at those data sets. I'm going to turn this off real quick.